Good morning, everybody. Once again, join the Pear Deck by hitting the link in the chat box or using the code in the top right of the Microsoft Teams screen. I want you to show your work on Pear Deck or show your work on notebook paper and then put your answers on Pear Deck. It says solve and graph each solution. So solve and graph each inequality. That is the task here. Solve and graph each inequality. Ask questions. You have about 15 minutes to do these 4 problems. So please ask questions if you need to, but make sure you're on task. Thank you. The only website we should be on right now is Pear Deck. No YouTube, no other websites. Welcome to class. There is 13, well, I guess 14 minutes left to complete these 4 problems. Please make sure you're on task. Show your work on Pear Deck or show your work on notebook paper. But if you show it on notebook paper, I won't really be able to help you unless you ask specific questions.
Mr. R, I forgot. Whenever the sign, whenever it changes from positive to negative near the end of the equation, does the sign flip always or just when it's negative?
Yeah, so whenever you multiply or divide over that symbol with a negative, that's when it flips. Great question. I'm glad you asked because other people need to make sure that they have that too. So anytime you multiply or divide with a negative across that symbol, that is when it's going to flip. When you multiply or divide with a negative across the symbol.
Okay, thank you.
5 minutes left. Jessica, if you're here, I need you to join the pair deck or say something or indicate that you're paying attention in any way. Elliot, are you working on notebook paper? Because you still need to join the pair deck. All right, it's 9:15, so you have 1 minute left. If you just joined us, we're about to review our independent practice, which was to start class. If you were unable to finish them, please make sure you're asking questions, paying attention. We are going to be moving on to a new topic shortly after this, so please make sure you're paying attention. All right, it is 9:16, so it's time for review. The way we're going to review this time today is I'm going to post the answers, and I'd like you to ask questions. So here's the first one. You can see the first step I took was distributive property. Okay, and I'll annotate the work. I used distributive property right here, and that left me with 2x plus 2. Then I did the inverse operations on the plus 2x with its inverse, minus 2x on both sides. Same signs right here, so I added in, I kept the sign. -3 and -2 make -5. The inverse of -5 is plus 5 on both sides. 2 plus 5 is 7. Well, obviously -5 doesn't go into 7, but we still need to divide it. It was multiplying, so our task is to divide. So we divide there, and the result is 7 over -5, or -7/5, or -1.5, -1.4, or you could say -1 2/5. That would also work. You could do -1 2/5. Any of those are equivalent representations. So you could do -1 2/5. That also works. Now, as far as the graph goes, you'll notice that the graph is an open circle. We need to make sure we talk about that today because we're going to be going into linear inequalities. We need to make sure we're talking about why it's an open circle shaded to the left. So first off, why did the sign flip? Annalise, you already asked the question, so let me throw that back to you. Why did the sign flip in the final answer? You can see it started up there. Go ahead.
It flipped because when you divided with a negative number.
Yeah, exactly correct. And so basically you're flipping from one side of the number line to the other. 7 divided by -5, that's a positive 7, but our result is a negative value. So we're going to flip that inequality symbol. So Aditya, why is it an open circle? Tell me why it's an open circle.
Because -1.4 is not an answer.
-1.4 is not included in the solution set. Can you characterize that a little more? What would happen if I plugged in -1.4 into x right up here? What would happen to the equation?
You wouldn't get the right answer.
Would I get a true or a false statement?
A false statement.
Exactly. I would get a false statement. I would get 7 is greater than 7. So that's false. It's not greater than 7. I would get 7 is greater than 7. So it's a false statement. It doesn't work. That's why it's an open circle, because it's not technically in the solution set. It is not a solution. It's not a solution. So -1.4 is not included in the solution set. It doesn't work. So any questions on the first item that we worked on? Any questions on the first item that you worked on? Let me know, Rastuda, if you got that correct. You did? Rastuda's shaking her head yes. Awesome. Love to see that. Anybody else get that one correct or incorrect and want to discuss where they made an error? That's always a helpful place to learn, is where did you make a mistake? Anyone? Okay, no one's going to say anything. Oh, Lola, go ahead, please.
I messed up because I didn't do the reciprocal. I added 2 to the -3, so I ended up with the wrong answer.
Right, so it sounds like, Lola, did you put 1x right there? Or -1?
Yeah, the answer I got was -1 for that, and it didn't work out for the rest of the problem.
Right, so that's a simple error. That's just a sign error. So you definitely want to be careful with those sign errors. You don't want to make a mistake because you added or subtracted incorrectly. When we return to the classroom, you'll have a calculator, a nice graphing calculator that we'll learn how to use right on your desk. In addition to that, you have a calculator on your phone right now. You have a calculator on Desmos. Please check yourself. Don't rush to get questions right and get them wrong because of the signs. So I'm just going to get rid of some of this so that I can redo it for the other classes. Okay, solid. So now we're going to move on to the next item, and we're trying to go with under a minute for each one. This one especially is quite short. I started by doing plus 10 on both sides, inverse operations. In doing that inverse operations, I get 20 minus 10 is 10. Now, this is x over 4, so the inverse operation is multiply by 4. You can see that I did x divided by 4 is less than or equal to 10. How did I get rid of it? I multiplied by 4 on both sides. So x is now isolated. 10 times 4 is 40. And notice that it does not flip. So it's x is less than or equal to 40. It doesn't flip because the 4 was a positive 4. And now let's talk about what it means that it's a closed circle. Let's go to Elliot. Why is this a closed circle, Elliot? Just please quickly speak. Why is this a closed circle?
Because that's an acceptable answer.
Exactly correct. Thank you. That is an acceptable answer, meaning it's a solution. If you plug in 40 right here, we can do it mentally very quickly. We won't even do it mentally. We'll actually show the work. 40 divided by 4 is plus 10 is less than or equal to 20. You can see that I just plugged in x. Well, first we'll start by dividing right here. Well, 40 divided by 4, that's 10. 10 plus 10 is less than or equal to 20. That's true. That's a true statement. So it's a true statement because 20 is less than or equal to 20. So it's true. If it was just less than and not equal to, it would be false. But because we plugged in the 40 there and it was or equal to, it works. So that's a true statement. Good question. Good answer, Elliot. Thank you. All right, we're going to move on now to the next item, which is item 3. Item 3 is a two-step equation similar to this one, or two-step inequality, I should say. Scroll down. And that brings us to this right here. So it's going to be pretty straightforward. Again, I'm going to do the inverse operations on the plus 10, which is minus 10, negative 26 minus 10. So this is another one of those double negatives. Same signs, add and keep. The only time a double negative makes a positive is when you're multiplying or dividing. But here we were subtracting. This is like I owe you $26 from Monday, and then I borrowed 10 more on Tuesday. Now I owe you $36. It's the sum of two negative numbers. Negative 36, and then I take inverse operations on the negative 6, divide by negative 6. That cancels out, and now I'm left with positive 6. But again, you'll notice that the solution set flips. The inequality symbol was greater than or equal to, but it ends up less than or equal to. Why? Because the negative right here makes that flip. So we got to make sure we flip the sign. We've already talked about what is and what is not a solution set, so I'm not going to go over it. But this is a closed circle because 6 works. And that brings us to the very last one. Oh, wait, I forgot to ask. Does anybody have any questions on this item? All right, nobody's asking anything. We're going to move on to this next one. We're going to subtract 5n on both sides, or you could subtract 3n. Either way, you're going to get the same answer. I just like by custom to move my variables to the left. 3n minus 5n is negative 2n. Add 1 to both sides. Negative 13 plus 1 is negative 12. Here you can see opposite signs. Opposite signs, we subtract the numbers and take the larger sign. The larger sign is the negative, and so when we subtract them, we get 12, and then we keep that negative sign. Divide by negative 12 and making sure to flip the sign, and it's an open circle because n cannot be 6. If you plug in 6 here, it'll be false. You'll get 17 is greater than 17, and it's not greater than 17. It's false. It doesn't work. We get 17 from 18 minus 1. That's 17. If we put a 6 right there, 3 times 6 is 18. Take away 1 is 17. 5 times 6 is 30. 30 minus 13 is 17. And we end up with 17 is greater than 17. That's false. Therefore, 6 is not a correct solution. All right, that was the review for today, this morning. And I'd like to pause there to take any questions that you guys have. Please ask if you have a question at this time on any of the items. If you got one wrong and you're not sure why you got it wrong, if you have anything that you want to go over, now is the perfect moment to discuss. Now is the perfect moment to discuss. Any questions on these 4 questions that we just did? Here's all 4 of them. There you can see all 4 at the same time. And I would be happy to help you out. Are there any questions about these? Anybody? No? Okay, well then we're going to move on. Are you sure there are no questions? All right, we're going to do this on Pear Deck. We're going to do one as a class and one independently. All right, I'm going to do 6. You guys are going to do 5. So you're going to do this on Pear Deck just so we don't get too bogged down. make sure you're on task, please. I will be closing tabs of those of you who are on videos and whatnot, so I don't want to be that guy, but this is a high school level course. I shouldn't even have to be doing that, but the facts are the facts. So if you find your apps randomly closing, it's because you're not paying attention properly. All right. You are choosing between two different event planning companies. Company A charges $5 per ticket sold to the event, and Company B charges $500. How many tickets must be sold for Company A to be a better value? So it says Company A charges $200 plus $5 per ticket. So there's that word per, which tells me my variable is going to be T equals tickets. T equals tickets. Now, the first time we read it, we want to just annotate that text. So we have Company A and we have Company B. And what is the actual question asking us? It says, how many tickets must be sold for Company A to be a better value? Well, we have to know what the word better value, what like this phrase means. Company A is a better value. What does that mean? Better value. We want A to be better value than B. Company A to be better value than B. Well, what does that mean when we think about the context of an inequality?
Company A to be greater than Company B.
Okay, you're on the right track. So when we talk about greater, you're saying you want it to be more expensive?
Company A to be less than
Yeah, we
Company
want
B?
A. So what Restuda first said, and I think then she had some tech problems, couldn't unmute to correct herself, but I think she immediately saw it, is that's super common. When we think better, we always think greater, right? When I did better than you in basketball because I scored more points. I did better than you in the race because my time was lower. So it's like better has a different meaning here. We want it to be less. We want it to be cheaper. Better value means cheaper than B. We want it A to be less than B. Okay, that's the first thing you have to establish is the relationship that we're looking for. So we want A to be less than B. Well, let's start by looking at Company A. What does Company A charge? Company A charges $200 plus 5 per ticket, 5T. This is the cost model for Company A, and we want that to be less than the cost model of Company B. Well, Company B charges a flat rate, $500. So if you only sell one ticket to your event, if you definitely want to go with Company A because they're only going to charge you $205, 200 plus 5 times 1. If you sell 10 tickets, that's 200 plus 5 times 10. Well, that's 50, so 250. That's cheaper. But there's a certain number. If I sell 1,000 tickets, if I sell 1,000 tickets, that's 200 plus 5 times 1,000. Well, that's pretty expensive. 5 times 1,000, that's 5,000. So I'm going to end up paying $5,200. Well, I should have definitely done Company B. Company B would only charge me $500. So it really depends on how many tickets I sell. So that's why it's important for me to use algebra here to figure out what number of tickets makes A the better value. That's what I'm trying to figure out. What number of tickets? So now I solve. Minus 200, minus 200. 5T less than 300. So the ticket proceeds need to be less than $300. Divide by the rate of change, which is 5, and I get T is less than 60. Well, what does that mean? T is less than 60. What does that actually mean? T is less than 60. Marilyn, what does that actually mean? T is less than 60. What does T represent? Morgan, give this context, please. Tap that unmute button and tell us, what does T is less than 60 mean?
t is less than 60 means that like you can have any amount of tickets, but you can't go up 60 tickets, or else you have to buy B.
Okay, so any amount of tickets less than 60. Does that include 60? Let's test it. Let's see if that includes 60. 200 plus 50 times 60 is less than 500. So we're saying what happens if you sell 60 tickets? Well, 50 times 60 is 300. 200 plus, no, it's not. Is it? 3,000. So I think I divided wrong. Nope. Oh, this isn't 50. It's supposed to be 5. I'm like, what? My bad. 5 times 60 is 300. Okay. So you can see here that no, we end up with 500 is less than 500. So if you sell exactly tickets, Morgan, if you sell exactly 60 tickets, which company would you choose? If you sold exactly 60 tickets.
Company A.
Why?
Because it's cheaper.
Is it cheaper? Look, we just did the math. 5 times
Wait,
60.
Same price. It's the same price.
So which one would you choose?
Company B, or both, or either.
Or either, yeah, that's the real answer, is that they're equal. It doesn't matter unless you can go on Yelp or TripAdvisor or Google and like check the reviews, right? And people are like, oh, well, company A, they're sloppy, they don't do a good job, they don't treat the guests with respect, definitely don't hire them. Maybe even if the price was cheaper, maybe if you sold 59 tickets, maybe it's worth $5 to go upgrade to that better value. But the key thing that we're trying to get you to realize is that inequalities here can be used to truly make choices. Inequalities can be used to make choices. And so it's important to have a sense of what your values are. I mean, if my customer reviews on company A are trash, I'm okay with spending more money to get higher quality from my company B. If company B says, all right, it's $500 no matter who shows up, but we're going to do a great job, and maybe it's fewer people than 60, but I still hire them. But mathematically, I'm going to go with anything less than 60. I'm going to go with company A. Unless it's the same, unless it's 60 people, then it's a pick 'em. You choose whatever you want. And then if it's greater than 60 people, you should go with company B. All right. This one is for you guys. Independent number 5. You're going to do the work on Pear Deck. Some of you probably have already done it. I'm going to look, and I'll have one student pick one student to explain. All right. So we're on independent number 5 now. You're going to do that on Pear Deck. Write your inequality. And we'll have somebody explain. Guys, make sure you clear off the left-hand box. I was just using that as scratch area. So clear off the left-hand box so you can do your math there. Now, Logan, check your symbol now. You want to be greater than 1,000. but you might want to be more than greater than 1,000. It says at least $1,000. Now that at least word is critical here. So what does the word at least mean? What does the word at least really tell us? At least $1,000. Is that your roof number or your floor number? So like Mo, you solved, but check your symbol. You're saying less than 1,000. They need at least 1,000. So consider what that means for the symbol. Right, Christian, nice work. I might have you explain. So you're on deck. Emily G, you're also on the right path, so I'm going to have you also be a person who can give us context, give us explanation. So we need to think about what the word at least means. What does it mean to need at least $1,000? So a lot of us have the sign a little backwards. At least means that that's the lowest I could be, which means I need to be greater than 1,000 or equal to 1,000. So Angel, looks like you have greater than, but we're missing that or equal to. Nice job, Elliot. You wrote the equation properly. Now solve, or the inequality properly. Restuda, same thing. You wrote it properly. Now solve. Give you guys about 45 more seconds to solve. Jessica, are you working on notebook paper? Or are you working on, what's it called? Pear Deck. Journey, Terry, Ariana, Shariah, are you working on notebook paper or Pear Deck, or are you not working at all?
I'm doing notebook.
I'm also doing notebook.
Okay, that's solid. That's fine. So long as you're working and are ready to produce results. All right, well, it is time to review. We're going to look at this question as a class, and then we're going to finish up our unit on scatter plots. So what we're going to look at specifically are two of your classmates' work. Allow me to read, please. It says the 8th grade class, and this one is annotated, so we really like that one. The 8th grade class is selling chocolate bars to save money for the end of year trip. They have earned $225 so far, and they earn $25 per day selling chocolate bars. Their goal is to earn at least $1,000. Right, solve, and graph and inequality represent the situation. So we're going to start with Christian, who right up here. Start, Christian, by telling us what was your variable and explain your inequality.
So my variable was D for each day that they would get $25, and mine's was it was that inequality symbol, but that's because they can either make exactly 1,000 or more than 1,000.
So imagine you were in this 8th grade class and you were selling these chocolate bars. What would you prefer, to be exactly at 1,000 or to be greater than 1,000?
Greater than 1,000.
When money is concerned, it's almost always or equal to, right? Because we want to, 1,000 is good, but wouldn't $1,500 be so much better? Because then you guys could maybe go out to like a free dinner or something, or go to the movies or something. I mean, money generally is going to be or equal to, and then you want to be on the greater side of that, or the lower side of that if you're thinking about cost. So anyway, please continue. So what was your exact equation? What does the 225 represent? What's the 25? Go ahead.
The 225 is how much money they already got, and 25D is $25 per each day. Then divide that by 775 for how much money they still need to have to get it, and then you divide it, and then you need to have 31 days or more than 31 days to get.
Okay, Emily, I noticed that when you made your graph, you did a closed circle. What happens at 31 days? Why is it a closed circle?
It's a closed circle because it can be greater than or equal to. So that means it can be 31 or it can be more than 31 days or
Yes.
bars.
You're right. 31 days of selling chocolate bars. So 31 times 25, which is $25 per day, is 775. If you add 775 to 225, they'll be exactly at $1,000. On day 31, they'll be exactly at $1,000. So that's why this point exists, because it'll be a conclusively true point. So that pretty much wraps up our study of single variable inequalities. And we only have 20 minutes left, which is what it is. So what we're going to do is now wrap up scatter plots. So we're kind of doing a little 2 topics in one day type situation. But before we move on, are there any questions about this? Like, because I saw some people did less than. Does anybody want to talk about why they did less than or anything of that nature? Does anybody want to discuss this further? Please ask a question. If you have it, you don't need to raise your hand. You could just ask, and then we'll move on. All right? New? Then we'll move on now. So that's going to bring us to mini lesson on scatter plots. We're going to finish up scatter plots right now. So we're going to talk about residuals and outliers. So you're going to want to, in your notebook, like, or flip back to your notes when we were working on scatter plots. So scatter plots, and then we're going to talk about residuals first. You guys ready? This will wrap up our class for the last 18 minutes. Solid. So let's get it cracking. So a scatter plot, as you know, is a collection of data points that will generally show a trend. And the trend can be modeled by a line of best fit. So the line of best fit is a model which shows the trend. Here you can see a negative correlation. It's pretty strong. They're pretty closely packed. Here you can see a positive strong correlation. They're pretty closely packed. Remember that the correlation coefficient R represents that correlation, and the closer it is to 1, the stronger it is. So this might be R equals 0.8, and this could be R equals negative 0.8. This is maybe a no correlation or a weak positive correlation. In fact, I would call it a weak positive correlation. So, but it's really hard to tell because the dots are kind of everywhere. Now, the third thing we're going to talk about after correlation and correlation coefficient is the idea of a residual. A residual is defined as the difference between the actual value of the dependent variable and the value predicted by the model. The model is the line of best fit. So to put that into simple English, the model is the line of best fit. So a model that minimizes residual means the line that best fits the data for real. Minimizes means makes smaller. So you don't want big residuals, you want tiny residuals. Residuals are the distance between the dots and the line of best fit. So which graph here minimizes residuals? Yeah, it's the middle graph because it's the graph that best fits the data. So take a moment to please copy down the definition and then also put the definition in your own words. What is a graph that minimizes residuals? What is a graph that minimizes residuals? A residual, once again, is the difference between the actual value and the predicted value. So how does the line compare to the dots? The third graph has bad residuals. They're too big. This is way too far away. That point, that furthest point away, is way too far away. This is a bad graph because, again, look at this point. Look how far away it is from the line. It's not a good line of best fit. Therefore, the residuals are very large. And this is a good line because the residuals are tiny. So the next slide, we're going to see more of the same. It has the exact same definition, so if you still need it. And this is a released EOC item. In the 7 or 8 years that I've taught this class, okay, I've only seen one question like this, and it was this one. So we are not going to talk about this often, but we are talking about it right now. Independent released EOC item. End of course exam is the EOC. Which graph minimizes residuals? Which graph minimizes residuals? So go ahead and put your answer on Pear Deck, and then we can count the residuals. You can actually count the residuals. How far away are you? Here, look, that's a residual of 2. This is a residual of 2. This one has residuals of 2 units away. And you can see that it's 2 units away because I literally just counted it. It's got residuals of 2. This one, look how far this is from the line. 1, 2, 3, 4. That's a residual of 4. We're looking for the furthest point away. This one is like 3.5. I don't know, 4. Looks like about 4. That's a residual of 4. This one, the furthest one away is this, and it's only 1.5, 1.5. So which graph minimizes residuals? It's D, which most of you answered on Pear Deck already. It's pretty straightforward, especially if you just think about minimizing residuals just means a graph that has the line of best fit, and it's an actual line of best fit. So D is that. This is the only question I've ever seen on the EOC to talk about residuals. We're not going to talk about this again. We're going to talk about it today. That's it. And then we're going to talk about it a day or 2 days before the EOC. I'm going to give you this exact same slide again, and we'll say, hey, what are residuals? Oh, yeah, it just means the line that actually fits. Just in case you get this question, I want you to be prepared for it. The next topic is outliers. So many of us already know what an outlier is, but imagine for a moment Shaquille O'Neal, famous basketball player, all-star, NBA champion, huge human being. He's enormous. He's 7'2". He's probably 330 pounds. He's a big guy, big human being. Imagine if he was in a kindergarten classroom. Does he fit? Why not? Why doesn't he fit? What makes him an outlier? There's so many reasons.
Because he's much taller than everyone else in the room.
Sure, that's one reason. There's a lot more.
He's old.
He's older. They're 5-year-olds and 3-year-olds and etc. He's an adult. He's older. He's got 5 NBA championships. I'm pretty sure nobody in that classroom other than him has an NBA championship ring. He can dunk. Have you seen a 5-year-old dunk? They can't dunk. He's incredibly wealthy. They have like cookies, and that's the extent of a 5-year-old's wealth is like, I have a cookie today. And then they eat the cookie and their wealth is gone. But he has millions and millions of dollars. He's famous. He's on TV, etc. He's an outlier. So if you think about this graph, the cluster here is the ages of the kindergartners, and maybe this is Shaq and this is the teacher or whatever. That's Shaq and that's the teacher. We don't know. But outliers are points that do not fit within the rest of the data set on a what is it called? A scatter plot. So please copy down this definition here. Outlier is simply a data set. Of a data set is a point that does not fit the rest of the data. An outlier in our digital classroom is me. I'm an outlier because I am like 20 years older than you guys. And I mean, I don't know, like there's other reasons that you are unique and a character of who you are, your character, your personality, your accomplishments make you an outlier on some thing, you know, whatever it may be. I don't know exactly what it is because, I mean, it's hard to know. For me, age is really easy since you guys are all, 13 and 14 years old and I'm 30 years old. So that's obviously different. So yeah, outliers are going to be data points that don't fit within the rest of the data, which brings us to our independent practice about outliers. Michelle is buying a computer for college and compiled a data set showing the price and quality rating for various options. So on her x-axis, you can see Michelle made a price axis, and on the y-axis, a quality ratings axis. Circle the outliers and state what these points represent. Draw a line of best fit that minimizes residuals. Circle the outliers and state what the points represent. Draw a line of best fit that minimizes residuals. And then finally, which laptop, if you were Michelle, what should she choose? If you were Michelle, that's like the question that's not listed. If you were Michelle, what should you choose? Here, I'll add that to the next class. So it also says state what they represent. What do the outliers represent? Like, you know, what do their combinations represent in the context of the problem? Mo, we're only circling the outliers. Which are the data points that do not fit with the cluster? Which are the data points which don't fit with the trend? All right, most of you are done with some kind of explanation. Now, don't forget to do the second one, which is to draw a line of best fit, which minimizes residuals. You want to minimize your residuals. So that means it needs to be dead center as much as possible in between those data points. So use that line tool to do a really nice line that cuts the data right in half as much as possible to minimize residuals. All right, it's time to take a look so that we can wrap up class here. So let's start with this student right here. This is Jessica. Jessica circled B and D. And this student right here is Elliot, also circled B and D. He says D is a high price, low quality. B is a high quality, low price. This student says if $2,000 computer quality rating is $65 and a computer that costs $500, you know, I don't know that they actually finished the thought, but does somebody want to put this in context? What does this mean? What does this mean? Like, which computer, you know, what are we looking at here? Aditya, why don't you unmute? We haven't heard from you today. Let's give you a swing at the bat. What are the outliers and why?
The outliers are B and D, and because B has a good rating and it is like well priced, but D has a lowish rating and it's pricey.
Yeah. So which one? If you're Michelle, what are you choosing here before you go to college?
B.
Absolutely, right? B is a low price but a high rating, whereas D is very expensive and has a pretty medium rating. I would say D is like Apple computers, right? And I know there's probably some Apple stands here, but they're just overrated in my opinion. A is like the Chromebook that you're on right now. I don't know. C is like some random Dell. And then B is this incredible deal that you get on Black Friday or whatever that is like super low priced for the quality that you get. So that's what it means to be an outlier. B and D are outlier. And then the cluster is all of these points right here. This is the cluster where all the points generally lie. And then we can say that the trend line, the line of best fit, should go between the data set. You want to have roughly the same number above the line as you do below the line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 or so, whatever. So that's pretty much it. Now, with our last 4 minutes, we are going to preview what we are working on next week. Linear inequalities. You guys don't do anything. Don't touch that dial, all right? We're not done yet. So let's quickly go to Desmos and let's talk about this function. Y equals 3 over 4. So rise 3, run 4, x minus 2. So you can see a few important points. 0, -2 is our y-intercept. There's our y-intercept. So simple. We can also see our slope by going to this point right here. That's 1. Is that 2? That's 2, comma 2, comma. That's not a good point. Here's 1. 4, 1. 4, 1. You can see we can see 4, comma 1, and we can see our slope pretty readily here. The slope is rise 3 units up 1, 2, 3 over 4 units. So does anybody have a question about what this right here? We found our slope-intercept form. Our y-intercept is at -2, and we can count the slope by going from point to point. Here's 1 up 3 over 4. Now, we're going to make instead a linear inequality, and you're going to see something dramatic happen to the graph. I'm going to get rid of the equal sign, and I'm going to replace it with a greater than sign. So now there's shading involved. It's greater than. So where is it shaded? Above the line or below the line?
Above.
Exactly correct. Now, what if we make it less than? Where's it going to be shaded, Tyron? Below. Now let's make it equal to or not equal to. What's happening when I make it equal to versus not equal to? What's happening to the line? Here it is not equal to. So now it's just less than. So it's shaded below. But when we make it equal to, what happens to the line? Anybody can see the difference? Nobody?
The line becomes solid, but when it's just a greater than or less than sign, the line is a dotted line.
Exactly correct. And that indicates whether or not it's a solution. So any number in the shaded area will make it true. If I put this point at 10.5, 10-5, it'll be true when you plug it in. So that's what we're going to be looking at when we return to class next week. Okay, that's what we're going to be looking at when we return to class on Tuesday of next week. So I will talk to everybody. Let me, before I dismiss you, just double check to see what kind of assignments we have as we approach the end of the quarter. You know, the end of the quarter is today. So any assignments that are outstanding need to be turned in. It's 9:59. Don't go anywhere. Classwork. So just take a quick look here. First off, I'm going to get rid of this. We're not ready for this yet. So clip that. That's gone. But you still have some assignments. This quizzes, scatter plot, and this is the last assignment for the second quarter. You have 2 iReady lessons that are due Wednesday they were due 2 days ago, but you know, you can still turn it in for full credit. I will be doing grades today. Any missing assignments, including the module assessment. If you didn't do this, welcome to your F. You have to get your assignments done. So please get these assignments done. This is the end of the quarter. Don't slip up now. So please make sure today that you have completed the iReady lesson. I'll put this in the grade book today. Please make sure that you're done with your assignments. You guys have a great weekend and get some rest and whatnot. Good work today, and we will pick up next week on Tuesday. All right, bye everybody.
Bye. Have a good day.
You too. Have a good day. Good weekend. See you later.